Hello, it's me, and I'm here to address the challenges that I put forth. As you recall, in the last video, I had a challenge to solve this layer by layer by layer, and a challenge to solve this using only the algorithms that I talked about. So what I'm going to do is I'm going to go ahead and do the 3x3 solve first before hitting this. So this is the classic puzzle that's made up of one set of corners, a set of edges, and centers. So it has the minimalistic amount of what you need. So we're going to scramble this up. Now understand, the challenge of this was not how fast you can do it and how efficient you can do it, but can you do it with the least amount of algorithms? It does mean we have to do a little bit more strategy, but least amount of algorithms. And the thing about this is we have every type of move, 90-degree moves, which means that orientation and permutation are problems with all of these things. So I've not shown you how to deal with orientation of corners. And to those that have tried that and had difficulties, that's probably what you had an issue with. Because I didn't show you any corner orientation issues. So there you have it, the archetypic iconoclastic scramble of a 3x3. So first step, first layer, we'll hit this and we'll put all the edges in place. Okay, here's a red edges over here. Where's some more edges? Here's a green and yellow. We match this up to its proper center and simply bring it up. So now this is in. Okay, if you find this is in the wrong place, we got to bring it down here. I don't want to mess with this. So I'll just take these edges out of the way and simply move it down. And I can move these back. Now I'm going to line this up with its proper center. Here it is. Splat. There it is. Okay, where's the last of the greens? It's here. So I'm just going to move these out of the way, bring this down, move this back. Now I'm going to take this to the white, move it up. It's intuitive because there's really no algorithms that you need to know. Corners, just do the same way as this. R-I-D-I, R-D. So green, orange, and white. Green, orange, and white. Put it right under where it's supposed to be, the corner right under here, and just keep doing R-I-D-I, R-D until you like where it's at. And that's fine over here. Okay, where's another one? Here's another one. Orange and yellow, R-I-D-I, R-D, that's it. Another orange, here's a red and white here. And you can keep doing your R-I-D-I, R-D. And to the you advanced solvers, yes, I know there's a faster way, but that's not what this is about. This is here. If you want to rotate that around, just keep doing R-I-D-I, R-Ds until you do that, and it shall be done. Okay. So you're thinking, fine, that's easy enough, but you promised me no new algorithms. You've got this done. So what you're going to do is you're going to do the middle layer. This is a layer by layer approach. So just turn this 90 degrees. Now we got to get these guys in, and we can rotate around here to get these guys in. Here's how you do this. We want to put edges in. These are edges. So we're going to use our edge algorithms. And we're going to use our adjacent edge algorithms. Look for all the edges on the top that don't have blue. So here's a red and yellow. Match this up with the center. This needs to move down here. Well, we know how to do that. We just have to move this adjacently. So we'll do an adjacent edge swap. We don't care where this goes, but at least this will move into place over here. So just do an adjacent edge swap. You won't mess this up. You'll do stuff here, but who cares? 2R, U, 2R, U, 2R, 2U, 2R, 2U, 2R, U, 2R, UI, 2R. Bang, there it is. Okay, how about this? All right, move this here. Now this doesn't go down here, so I don't swap it here. This has to go to here. So what I'm going to do is still hold it here, and I'm just going to make a turn over here. I'm just going to do a U-turn. Don't worry about what turn that was, but basically I'm going to turn it here so that this is in front of me. So now I can do an adjacent edge swap over here. And then I'll move it back when I'm done. It's not going to touch any of these pieces here, but what I'm going to do is I'm going to move this over here and swap these two. What that's going to do is it's going to take this piece and put it back over here. So do it again. So if you have to swap these two, just line it up and swap it. If you have to swap these two, line this up over here, make a turn here, and then swap it. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R. Simply move it back, and you can see that that's placed. This is now in line to come to here. 2RU, 2RU, 2R, 2U, 2R, 2U. So this middle layer is an edges only layer, so we're just doing an edge algorithm. And let's see what else we have. Well, almost everything is in, except this has to come down to here. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R, and it's done. All these are in. What if you get a situation like this, where it's in, but it's flipped? Well, holding to this technique, just do an adjacent edge swap to put it up here, and then you can reposition it. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2RUI, 2R. So now it's up here, put it where it needs to be over here, and now do that technique, put it down here, and flip it, and swap it rather. 2RU, 2RU, 2R, 2U, 2R, 2U, 2RU, 2R, UI, 2R, move it back, and then it's in. Now the last layer, what do we do about that? Well, we have to flip these edges. How are we going to do that? How are we going to do that without adding an algorithm? And I can tell you an algorithm right now that can do it, but that wasn't the challenge. The challenge was to try to do this only with the algorithms given. Well, what I'm going to do, actually, is I'm going to go ahead and flip these the way that I would with corners. The way that I did with corners is I did an RI, DI, RD, and that's exactly what I'm going to do. But I have to be careful which layers I'm using. My R's and RI's are still going to be this. But my D can't just be the bottom because I'm not getting this in it. My D has to include this. So basically, my D's and my DI's are going to be this layer over here. And I'm going to do the same technique that I did to move this in. So I'm going to RI, DI, RD this until it's up. So RI, DI, RD, RI, DI, RD, RI, DI, RD. And now it's up. So now I move this into place and do the same thing. RI, DI, RD, RI, DI, RD, RI, DI, RD. And now this is up. So we have all of these oriented up, and it looks like everything is fine, but don't be too confident, because always what's going to happen is one corner will be out. The price that we paid for this technique is one corner is out. But that's okay. All we have to do is put this corner back in. Find it up here, put it in the right place, go ahead and do that swinging U technique to bring that back. And the good thing about the swinging U technique is that unlike a corner swap here, which is another technique, it won't cause placement issues there. That's the joy of this swinging U technique. So put this over here, 2R, swing the U to an L position, 2L, swing it to an R position, 2R, swing it to an L position, 2L. And now you can see you're back. So that's how to get these flipped up without using any new algorithms, just using RIDA, RD. The price that you paid is one of your corners will be over here, easily placed by our swinging U technique. Now that we have that, we simply do it the same way we did this. What we're going to do now is we're going to get the corners, we're going to put the corners back in, orient the corners by doing RIDI, RD. So just pick anywhere to start. We'll start with this, RIDI, RD, RIDI, RD. This is in, swing this around, RIDI, RD, RIDI, RD, and we keep going. Now this is in, swing this around. Now you can even count how many RIDI, RDs that you have, but we've already done that. And now we put this one in. And magically, all these will be fine. So now we find the two corners that are in, which is this. Do an adjacent corner swap. 2RU, 2RUI, 2R, UID, 2R, UI, 2R, U, 2R. This goes back. And now we just do edge swaps. And they're both opposite edge swaps. 2R, 2U, 2R, 2U, 2R, 2U. We've caused placement issues over here. We will not run into any problems with parity, so we just move this into position, do another opposite edge swap over here, 2R, 2U, 2R, 2U, 2R, 2U. And there you have it, your 3x3 solve just with those four algorithms. And that is the answer to that challenge. Now, what about this guy? Did you try it? Did you do it layer by layer by layer? Let's do a scramble and see how we can work our way through it. Now I'll tell you, this is not for the basics. This is not for the beginners. I'm about to add algorithms and do a lot of complicated and bizarre things, because this was more for those that are doing twisty puzzle advanced studies. Advanced studies in twisty puzzling. Okay, so here's how we can do this. I'm going to start off with green. I'm going to put edges in first, green and yellow. Right next to it will be green and white. Find it right over here. Turn it, pop it in position. Now I'm going to put the green corners. Here's some over here. I just have to orient them right. So I kind of have to move these out of this position, which is easy enough to do. Move it like so, take it out. So what I'm going to do is here's a yellow and green. Any yellow and green that fits here, it doesn't really matter. Take it out of the way, move it down, move it in, move it up. So that's in here. Let's pop this one in here. The orange, green, and white. Where are you? Right over here. Turn it in, down, and up. Now next, these guys. Well, I gotta get this away from each other, so I'm just gonna move this down like so. Turn, turn. And now this has to go in, turn, turn, and up. So first layer is done. Now that was too doggone easy. And usually it doesn't happen easy like that. What if you got something like this? Here's a situation that you might end up with. What if it's down over here? What do I do about that? Well, not too difficult. I'm just going to put it right under where I want it to be. Double turn it so that this is up here. Then I'm going to turn this out of the way. And now I can bring this down like so. Double turn this here, bring it up. So now it's out of that position and can easily come down like so. Okay, this layer is done here. Now this layer. So what I'm going to do is I'm going to take every piece here that belongs down here, and I'm going to do a little algorithm to take this and move it down to this area over here. That's going to be 2U, F, 2U, F, 2U, 2F, 2U, 2F, 2U, F, 2U, Fi, 2U. Pops it into there. Now what else? Well, I've got this, which can go to here. In this case, to move it to the left side, I'll do 2U, Fi, 2U, Fi, 2U, 2F, 2U, 2F, 2U, Fi, 2U, F, 2U, pops it into there. Now what? This guy wants to come down here. Same thing, 2U, F, 2U, F, 2U, 2F, 2U, 2F, 2U, F, 2U, Fi, 2U. Now, do you guys see what I'm doing there? Anyway, so now that's in here. I'm actually not doing a new algorithm. I'm doing the same algorithm, an adjacent edge swap, just from this perspective. This will come down to here, 2U, Fi, 2U, Fi, 2U, 2F, 2U, 2F, 2U, Fi, 2U, F, 2U. And we're done over here. Now we just got to flip these two. Well, how are we going to do that? All right, so what we're going to do in order to get out of this, I'm going to do a 2B and then a 2D. And then from there, I'm going to do a 2R, 2F, 2R, 2F, 2R, 2F, then do another 2B, 2D, and we're done. We did that. Now, I didn't go through that in detail, but you're supposed to notice what I did. I actually didn't do anything new with that. Now, the last layer can actually be a lot more complicated with that. Sometimes you get something like this. Okay, you got these in, but these corners are all gone. So this is good, but we've got a problem with these. These two have to be flip-flopped. So here's a really long, convoluted algorithm to do that, to flip-flop these two. Basically, what I'm going to do is 2U, F, 2U, Fi, 2U, Fi, D, 2U, Fi, 2U, F, 2U, and then DI, and then immediately do 2R, 2F, 2R, 2F, 2R, 2F, and it's done. They got flip-flopped. Anyway, so that's how you can do layer by layer by layer. And without getting into any details of what those algorithms were, can you guys guess what I did and how I came up with those algorithms? And I'll tell you, I didn't memorize any of them. They all just kind of got derived. So that's the answer to the challenge, and we will move on with the next step. We're going to go to the next level here, which is the 3x3x4, and this fulfills another request that I had, which was to go through this puzzle over here. Now, I'm not going to add any new algorithms except for one, but it's not really something that I've added. I did go through this. It's a way to fix a placement parity issue that can happen with it. You actually don't have to use it. You can work through one of the parity situations that happen without that, but it's something that is probably going to be useful. Anyway, to solve this, really, in content, this is really kind of the same puzzle as this, the 3x3x2. Because when you think about it, this layer only scrambles with this layer. Even though I have 4 layers, this is really 2 puzzles in one because this layer only scrambles with this layer. In essence, making this and this a 3x3x2. And this layer only scrambles with this layer. In essence, making this a 3x3x2. So what you have really is 2 3x3x2s sandwiched together. Notice every time I move this, these layers here only scramble with each other, and the top and the bottom only scramble with each other. So you should be able to solve this the same way as solving this one. But I'm going to do it in a slightly different way. And I'm going to reveal why I'm doing it that way at the very end, because I'm going to have to go beyond the basics with the next tutorial with this. But let me show you an alternative way that you might not have seen. And if you've not solved this before, you can easily solve it this way. So as we're scrambling this, notice there is a limitation in my scramble. And as you pay attention to how puzzles are put together, that's oftentimes a clue regarding how to solve it. Because the limitations with this scramble is the fact that because I can't make a 90-degree turn followed by another one, it follows the same limitations as this. We're scrambling an odd layer into an even layer, therefore I can't do this turn. I can only do this 3 layer to 3 layer. I'm only scrambling the top with the bottom and the middle with the middle. So I'm really doing a scramble of 2 puzzles in one. So I'm going to keep doing this, get a good scramble here. And let's see if we can navigate our way through this one without really changing much strategies. Just maybe adding a slight layer of complexity to it. Okay. Pretty good? We like? Sure, why not? That works a little bit more perhaps. Okay, so what do we think? Now, here's what you could do. There's no reason why you can't solve this doing the top and the bottom just like this and doing the middle 2 just like this. Or for that token, you can solve the middle 2 just like this and the top and the bottom just like this. You just have to coordinate the last bit together. If you'd like me to solve it like that at some point, I can. But in the meantime, I'm gonna do it a slightly different way. I'm gonna solve this layer by layer by layer by layer. So the first is to do a top layer. One of the advantages of having a center is you know what color that side is supposed to be. When you have a 2x2, this could really be any color. When you scramble this, you don't know that blue's on top. Blue can be here, here, or here. It's not definite. It's kind of your choice, but that could become an issue too at some point. Here, we know exactly what color is supposed to be where. So over here, this is going to be the yellow. So too, I've got the yellow here. What's supposed to come over to the other side? What's just to the right? What's just to the left? Well, here's an orange rather. This is orange. This is yellow up here, orange. Just to the right of orange is blue. So I know that the blue center is supposed to be here. I search around for it. I find it here. I just move it in. So too, we put the edges in first. So what's right next to blue? Well, right next to blue, on this side is going to be yellow. On this side is probably going to be red. Now, if you don't know the color scheme and you weren't sure if it was green or not, again, you can check a corner and see that this is orange over here, orange over here. Right to the left of orange is green, so to the left of this orange must be green. So again, I'm not big into memorizing, so if you don't want to do it that way, more power to you. This is the last one in, so bang. Now, commonly this is called getting the cross because you have a cross that's in here. Now that we have these, let's put our corners in the same way using our swing up technique. So here's on the bottom here, yellow, orange, and green. Orange and green here. So I'm going to put this in a position where 2R will place it into here. 2R. And then swing it to the left side, 2L. Swing it back to the right side, 2R, swing it to the left side, 2L. So this is in. So very quickly and succinctly we can put this in, orange and blue. This is orange and blue here. So 2R, see this here, move it to the L position, 2L, swing it, and you'll get pretty quick with it after a while. So there that is over here. Now what? We got blue and red. Blue and red, why don't we move that into position? Place it to where it's going to come into here. We have a yellow one, but you can see it's not the right one. We like this one better. 2R, swing it, 2L, swing it, 2R, swing it, 2L. Don't even worry about which U it is. You should be able to know it by just swinging it to the area that it's supposed to be. L's instead of R's, R's instead of L's. The last one is here, swing it here, or rather do a 2R, swing it to the L position, 2L, swing it to the R, and done. Okay, so this layer is done. The next layer over here, what we want to do first is we want to place the edges here. So this is in, this is in, this is not in, this is in. In order to place this one over here, put the center, actually instead of calling them centers, I'm still going to call these edges because in reality, this puzzle is two 3x3x2s. And a 3x3x2 only has centers here and here. These are the true centers. I'm really just going to call these edges. So move this to the side, any side. And I need to put this into this position. So double turn it so that you move it to this layer. Move this in. And only move this layer over here because you've got this poking up here, and then move it down. Then you'll find that that's in. So this one was particularly easy. Let's do it a little harder. Okay, so you see the green here. I've got to move an orange one in, so I find an orange one. It's over here, just move it to the side. It can be this side or this side, doesn't matter. So take this, move this up, move this orange in, just in this layer, and move it down, so that's in. Blue's here, got to find the red one. Here's a red one. Double turn it up, move this red one in place, and move it down. So easy to do, all these are in. To move these corners in, you do the same way. Nothing is new with this. I'm not adding any algorithms. The only difference is I have the yellow and the white color here. This one doesn't have a top color or a bottom color to guide us. So what we have to do is we have to use a little bit of deductive reasoning. I want the red and the green. Well, here's a red and green over here, but does it belong up here? Because the red and green also belongs here. You can tell this belongs here because if you flip this down here, if you move this here, it flips. Because this red is lined up with red here, and this green is lined up with green here, this one actually belongs up here. If you were to place it in this position by doing that same technique, you have it here. Let's say we move it into this position so that this with the 2R will come over here, like so. You can see it's going to be upside down. So that way you know this is the wrong one. So we're going to look to the layer here to see if another red and green is here, and we don't find it. So which means it's down here somewhere. So let's move to the next one. Green and orange. Find a green and orange. We don't see one here, so we move to the next. Orange and blue. Now sometimes all of them are in this layer, they're just in the wrong one. Rarely, but sometimes it happens. Okay, so here's an orange and blue. This is the correct orange and blue because when it flips, it's going to flip in the right position. Because this orange should be here, this blue should be here. Let's pull that up over there. Okay, so I'm going to do the same thing. This is now my up, and I'm going to be moving this layer independently, keeping this one the same. So I'm just going to move this over to here, and I'm going to do my 2R, then move it to the L position, 2L, move it to the R position, and 2R. Same thing, but I'm only moving this layer so I don't mess this guy up. So 2R, moving it here, then just move this layer to the L position, 2L, now move this to the R position, 2R, move this to the L position, and 2L. And as you can see, this is now in. So this layer, all this layer saw was turn, 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 turn. That's all it saw. While this was doing all the action. So now let's move on again. Blue and red. Here's a blue and red, and you can see it's the right one. So move it over here to R, swing the U to the L, to L, swing it to the R, to R, swing it to the L, to L. Now we move that back. So now this is in. Red and green. Here's a red and green, so it's all falling into place. Turn, swing, turn, swing, turn, swing, turn. Now, to those who do it the standard way, you may think it's a little cumbersome, but it actually goes pretty well with this. Green and orange. So you can see that this green and orange is the wrong one. So the other one is up here somewhere. It's right here. Move it into place. To R, swing the U, to L, swing the U, to R, swing the U, and to L. And now the second layer is done. So now these two layers are all derivative of these two layers. What that means is that none of these pieces are scrambled with any other layers. They're all in the right layer. They just have to be permuted or translated from one place to the next. And the way that we're going to do this is the same way that we did with the previous puzzles. I'm going to move these together and ignore this last layer for now. You don't have to do it that way. You could move it independently. It's just easier for me to do that. So the first step is put the corners in. Corner, corner, corner. None of the corners are in. So with none of the corners in, I'm going to do an adjacent corner swap. Now you have a choice. You could just isolate this layer, but we're not going to do that for the purposes of simplicity. So we do we're going to move these two together. To our U, to our UI, to R, turn 90 degrees, to R, UI, to R, U, to R. Somewhere here, there's two corners that are in. These are in. Move it to the left and do another adjacent corner swap. To our U, to our UI, to R, turn, to our UI, to R, U, to R. And now as you can see, all the corners are in. So this is in, and this is in. We can match these up. Now all we have are the edges. So we're just going to put the edges in with our edge swapping techniques. Adjacent edge swap, we'll put the red one in. This is already in, so we have to our U, to our U, to our to U, to our to U, to our U, to our UI, to R. It just leaves these two, to our U, to our U, to our to U, to our to U, to our U, to our UI, to R. Now we just have the top layer, this guy over here. Same thing, corners, corners, none of the corners are in, so we just do a random corner swap. To our U, to our UI, to R, turn, turn, to our UI, to our U, to R. Bring this back, find the two corners that are in, these two, move it to the left, do another corner swap. To our U, to our UI, to R, UI, D, to our UI, to our U, to R. Going fast through that because I've already gone through the corner swaps, the adjacent corner swaps. So now we just have to do the edge swaps. Well, we can do an adjacent edge swap over here. Now when we do these adjacent edge swaps, something's going to happen with this puzzle that didn't happen with this. And that's going to be when we swap these two, because the edges are no longer hidden, we're going to see a swapping of these edges over here. So these are going to end up swapping. So let's go ahead and swap these two and see what happens. Okay, adjacent edge swap. To our U, to our U, to our to U, to our to U, to our U, to our UI, to R. So this is swapped in place. Now we have to swap these two. Now notice it caused placement parity over here, misplacement here. So I'm going to keep holding it with this to the left. Now the other thing that I guess I should have pointed out that I didn't is when I was moving just this piece, I would turn the whole puzzle. When I'm just moving this layer, I just turn this and this when I'm doing my edge, my corner swapping. So what's not participating in the solve or the scramble stays exactly put. So I'm keeping this put. And when I did my corner swaps, I just moved this layer and this layer. So in the middle, I did my UI D, whereas when I was just moving these, both of these in the middle of the algorithm, I turned the whole puzzle. So coming over here, I'm going to do another adjacent edge swap in order to put these in. Or what I could do is I could do an opposite edge swap to get this green to here. Why don't I do that? To 2u, 2r, 2u, 2r, 2u. That brought these back, but now we've got these to go. I'm actually going to just move this into here. Now, you're probably anticipating a little bit of a problem here. And that problem is the fact that if I swap these back, I'm going to end up and be stuck with placement issues here. So how do I get out of that? Anyway, we're going to swap these and see what happens. 2r, u, 2r, u, 2r, 2u, 2r, 2u, 2r, u, 2r, ui, 2r. All this is in, but now we're stuck with this. These two have to be swapped. So we have a choice. I've actually introduced this algorithm, so I don't feel too bad about introducing it again, but there is a fix for this, which is what I call the URF'd algorithm. What this does is this will swap these two. That instead of, what the puzzle did is the puzzle got fooled. When it swapped these two, it thought these two were the same piece, and these two are the same piece. So it swapped both of these. It kindly did that because now we can swap these as 4 pieces, which means it can be an even layer number of swaps, not an odd number of swaps. So we kind of fooled it that way in that swapping these two, swap these collectively, but now we can swap them individually. And that URF algorithm is hold this to the left, hold this to the right, and do 2u, where you split the u in the middle here, 2r, 2f, 2u, 2u, 2f, 2r, 2u, and it will flip those. So you can do that. Now there is a way of doing this without necessarily going through that that parity, and that's something that can be shown as well. If you really don't want to memorize anything new, but I would recommend that one. That one's a good one to know. But there is certainly a way to do this without having to do that URF algorithm. Now, this is kind of leading up to something, so I'm going to reveal exactly why I did it this way, even though it's a little bit different from the standard way. And that's because what I want to do is I want to apply this to certain puzzles that are also 3x3x4s, but have a very unique and interesting property. Because looming on the horizon, dark and mysterious, come the heavens cuboid, which is a variation of this, and of course, the hell's cuboid. Basically what these do is these take the 3x3x4 motif and they do something rather interesting. To those of you who know what a ghost cube is, a ghost cube takes a puzzle and makes it so that you have to solve it off center. So this actually over here, this is a 3x3x4. This is one layer here. Put this on camera maybe. One layer here, one layer here, another layer here, and another layer here. But notice, it almost seems like I can't turn any other layers, but you actually can. You just have to line up your edges together, like so, and once you do that, this is the actual shape of it. And let's see if I can get this right here. Move this into here, move this into here. Then I can move it. So this makes for a very interesting and challenging scramble. So this is a ghost type puzzle. This is also a 3x3x4, but it's organized even differently. This is solved like this. If I were to turn it like that, cut it down, that's how this is organized. This one is organized like this. So you can move it here and here. These 3 layers, it's organized like that, which makes it even harder. So when I come back with you next time, I'm going to use this exact same technique, and we're first going to solve the heavens cuboid before moving into deeper and darker stuff. So stay tuned, and thanks for watching.